Hello all, welcome to Tech with Says. Friends, I hope if you have seen my channel, I have made several videos on architectural patterns. And now I have started the series of system design. So like it's a second video, but I am planning to create many videos over coming months or maybe years as well. Before we deep dive into consistent hashing, let us understand the context of problem by an example. For example, if you have application which has many servers and they are serving various customers and users, and the keys or requests which are coming from the users, you are saving in those servers. So that is very good. But what happens in case you want to scale up and scale down? Scale up means you want to add a new server, and when you say scale down, it means that you want to remove a server, maybe for maintenance. So at that time, the problem is that load balancer was happily serving those previous servers and saving those keys or requests to those servers. But now you are going to add one more server or remove a server. So at that time, the keys need to be redistributed. So for that is distribution of keys, we use this algorithm, or you can say concept, which is comes handy so that we are able to distribute the keys efficiently. So let us understand how keys are distributed in a system which is non-distributed. So suppose you have a database server and application server and client, right? And client is sending the request to the app server, and app server is saving whatever key, say for example 5, a numeric number is sent to the database server and it is being saved. So next time, whenever client want that value back, it will be sent back by the app server because there is one server, so there is no issue of like where that value is being saved. So this is how it works very simply, very easily when we have just one server and there is no issue of scaling up and scaling down because of multiple servers. But for example, if you have an application that is kind of using the multiple servers and you have a load balancer in front of those servers, right? So what happens that whenever you are sending any request or any key to that application, load balancer has to distribute that key. So now saving thing is fine, but next time when user want to retrieve that key, it should know like, okay, from which server I have to access that. So for that, like it uses some kind of algorithm, kind say we can say that the hashing algorithm. So at that time, suppose we have four servers, right? Here in this context, and then the key value, suppose the key value is now 8. So we use a hashing function where we find the mod of 4. So suppose request value is 8, when we do a mod of 4. So it means like, because why 4? Because we have four servers, S0, S1, S2, S3. So that's why we are doing the mod of 4. I mean, you can take any hash function, but in this example, I have taken like mod of 4 hash function. So now what happens that it says, okay, value is 0. So 0 means whatever the request 8 is coming to the system, that's going to save to as 0 server. So first server will save this value happily. There's no issue. So now next time, suppose the key has 5. So same function you apply, then you get the like 5 mod 4 equal to 1. So now you are going to save that key in the server S1. Similarly, if you have like request or key as 6, then that comes to the 2. So now you have will save that value in the server 2. So now we see that, okay, we have a defined hash function. So whatever request is coming or key is coming, we are finding out the hash value of that. And then by that value, we are going to decide which server it should go, right? now the issue comes when and you want to scale your application, you want to add one more server. So at that time, suppose you're adding one more server S4. So now the issue is that you have to change your function, right? Because earlier you had four servers. At that time, you used the hash function as a request mod 4. But now because you have the five servers, so these servers now currently like S0 to S3 are serving all the requests. But now you also have to give work to the server. So you have to make sure that whenever you are now sending the request to the server, it also load from other servers because and now the logic has changed. What logic we used that was the request mod 4 has changed. Now we'll use the request mod 5. So now whatever the keys that were saved in S0, S1, S2, S3, that has to be again we have to distribute them in all the servers. So how we are going to do that? So we will use now the modify function because we have now five servers. So now with the same logic, the 8 mod of 5 is equal to 3. So now whatever the key 8, it does not belong to the server as not, it belongs to the server 3. Similarly, if you have a request 5, right, key 5, so now it belongs to the server 0. So now this key 8 should go to the server S3 and this key 5 should go to the server S0. Okay. Similarly, if you find other right, you will find that when you change your mod function because you want to distribute the existing keys to your new server as well because next time when you want to retrieve them you should know okay where it is being saved. So now what happens that there's a lot of shuffling happening. So now you will see, okay, now values are being changed here and there. So what happens that because you added one server in your application infrastructure, so all the keys are shuffled. So all the servers are like distressed. You have to do a lot of read, write, move data here and there. So a lot of work is there. So that's why it's a good solution like you can understand okay which server is having which key, but when you're adding a new server you have to change your function and distribute the keys. At that time a lot of shuffling is happening. It's overhead for our system, right? So and similarly suppose you are removing a server, same thing happens again. So for every single change, for every single server addition or deletion, you have to suffer a lot of keys, and it's not a good way, right? Because it's very annoying and also very time consuming process. So solution wise, solution is the consistent hashing. So in this algorithm, what we do, we assume that these four servers are a part of one ring, right? So suppose we had four servers in our previous example. So similarly we will take these four servers here also. So suppose now you have taken a ring and that has four servers S0, S1, S2, S3. Now and why we have positioned like this, suppose as at here and here. So maybe we will take like some kind of IP address or server name, and then we will hash those values. I mean, you can define your own hash function based upon your requirement. And first in this ring you can define okay, suppose you want to position your servers based on the IP, so you can position them, right? So maybe I mean I just showed like I say any degree here, but you can show like whatever you want as based on your function hash function. So what happens? Suppose now you have a like suppose you have new request. So and you are using some kind of function. So hash function, right? So that function will give you some value. Suppose it gave you 100. So you put this value 100 here because like suppose like 0 till 90 degree, then 180 degree. Okay, like a circle we have circle, right? So we can distribute the keys from 0 to 360 degree. So suppose when you have 100, So that comes after the S1. Next, suppose the key is 44. So that is going to come between the S0 and S1. Similarly, you can hash your keys and put them in the circle. After we have placed all the keys and the server based on the predefined hashing functions, then we have to start from the clockwise direction. You can use any direction, but you have to follow same logic every time. So if you start from the S naught, right, S zero, then yeah, you can see the keys as 44 and 52. So these keys will belong to the server S1. Similarly, when you start from S1 to S2, this key 100 is going to belong to server S2. So whatever in the clockwise direction the keys are looking at server, they are going to save over there. So for example, now if we see the S3, right? So in the S3, we will save the 212. So because this key in the clockwise direction is looking at the server S3. So this is a convention by which you can understand that which key is going to be saved in which server, and this is how we can basically map all the keys. But now the question comes, like when we are going to add any new server, what happens? Like how the consistent hashing is going to help us solve the problem which we saw in our previous setup, right? So now if you're adding a new server, so at that time what happens that suppose whatever the hashing you have done, so by that hash number, the server S5 is placed between S0 and S1. So now the key 44 is not looking at S1. Now, if you go from the clockwise direction, 44 will belong to the S5. So change will happen that now S1 will transfer 44 to the S5, right? So the change wise, whatever change we or shuffling of keys happening is happening between only S1 and S5. Other servers are not impacted. So this is the beauty of this algorithm, that whatever the shuffling of keys are happening because of adding a new server is limited. I mean, it's not like that there is no shuffling happening or there is no extra and write happening, but they are at very low number. Whatever setup we have seen in the previous example, where almost all the servers has to swap values or swap keys, but here only one server or two server are impacted. Okay, so this is how this is like a helpful to us when we want to add a new server, and then the shuffling of or the changing of keys happening at very low number, right? Similarly, if we want to add or remove a server, right? So suppose you want to remove a server and you remove the S1. So now S1 is gone. I mean, S1 is gone in the sense that it's not because it failed or something, but suppose you were serving your customers with four servers, but now the demand has gone down, and you feel that okay, my three servers are sufficient to cater that demand. So for that, we remove the server S1, maybe for some other application. So the keys, right, this 44, 52, and 100, they are looking at the S2. So in the clockwise direction, these three keys are going to be saved to S2. So now S1 will transfer these keys to the S2 server. So now we see that the change, right, that the actual impact on the ground is happening between the S1 server and S2 server. S3 and S0 are not impacted. So that's why connection hashing is really helpful algorithm or concept by which we can add or remove the server very smoothly, and the impact of the shuffling of keys or swapping of keys is very less. But if you are going to use like normal hashing function, at that time, whenever you are adding any new server or remove any new server, so at that time the change will be huge. You have almost all server will be feeling the heat, and they have to shuffle the keys here and there. So this is a very good algorithm by which we can fine tune or shuffle the keys when we are scaling up and down. But yeah, every solution has some problem, and it's also have like it's not like a you don't have to shuffle keys at all, but the impact is minimized. So that's all for this topic. Thank you very much for watching, and see you next time. Please leave comments or questions, and if you're liking my videos, please subscribe my channel and like the videos as well. Thank you very much.